Let's test a hypothesis about the mean when we have a small sample. Small sample means smaller than 30 observations. According to United States, mean quarters weigh 5.67 grams. A researcher is interested in determining whether the state quarter have a weight that is different from 5.67. He thinks that is different for some reason. The manufacturing processing have changed something. He believes that it's different right now. He randomly selects 18 state quarters, weighs them, and obtains the following data. This is the weight of 18 quarters. It's small because it's smaller than 30. Then at alpha 0.05 level of significance, this is the type 1 error that this researcher is willing to take. Is there evidence to conclude that the state quarter have a weight different than 5.67? Is this evidence enough evidence to state that the average, the mean weight is different to this value? Let's verify it. Let's do it. That is the objective. Okay, first of all, what is the claim? What is the belief of this researcher? He believes that it's different. That is my claim. He believes that it's different. He don't want to verify that it's equal. He believes that it's different. Then let's construct the alternative and the hypothesis. The alternative, remember, the null hypothesis is always the statement that there is no change. The mean weight of quarter is the same. And the alternative in this case will be the suspicion is different. Then my second step, determine the level of significance was given, was 5%. This is the type 1 error that this researcher is willing to take. He wants to make only in 5% of the cases that he select 18 quarters. In all possible way that he can obtain 18 quarters, he wants to make a mistake only in 5% of the cases. He expects that 5% of all possible sample will lead him to reject the null hypothesis when the null hypothesis is true. That is the meaning of significant level. Also, in this step, we need to verify assumption. What is the condition to the mathematical model that we use when we have a small sample? Will be t distribution. And in order to use t distribution, we need to verify that my sample comes from a population that is normally distributed. There is no outlier. We need to verify that. Then we can do this in using statistical software. We need to input in this software in a pp plot. That is the function in any statistical software. We input the 18 weight. We have 18 point here. And the output of this software is this graph, and this is a theoretical curve. If all points are close to this theoretical point inside these two curves, then we assume a normality of the population. So if the assumption of normality appears reasonable when we obtain this result. A StatCrunch, we don't have PP plot, we have QQ plot, which is similar. It's very similar to this. There are several ways to assess normality of a population using a sample. We can use also in StatCrunch, or you can do it manually to construct this box plot. And in this box plot, remember, this is the interquartile distance, interquartile range. And from this point, we can measure 1.5 interquartile range. This is a fence. And in this other direction, 1.5 this is the other fence. And we observe that there is no value outside this fence. Then there is no outliers. It's perfect. Then, since the data has no outlier and passed the normality test, we assume that all t-value obtained from samples, all t-values, all statistic t-values, when my sample is size 18, follow a t-distribution, and the degree of freedom will be 17. Let's continue. Step number 3, test a statistic. Remember, the test statistic give me how far away my evidence all from the center. The mean of all evidence is 5.720. How did I obtain this value? Remember, you can input the 18 weight in any software and any chip calculator that have statistical functions. You input this 18 value, and this software will give you the mean and the standard deviation. You need to show your work. Remember, you need to use formulas and tables to obtain this value. The formula for the mean will be the sum of all value divided by n, in this case 18, and the formula for the standard deviation is the sum of the deviation of all value respect to the mean, the deviation squared, divided by n minus 1. But if you cannot access Excel or StatCrunch, you have to do this calculation using a cheap calculator, then I strongly recommend to use this shortcut formula. N, the sum of all x squared minus the sum of all x squared divided by n times n minus 1. Then in this case, if you have the data, 18 data, 1, 2, 3, 4, 18 data, then you can obtain the sum here and you can obtain the mean divided by n. And how can you obtain the standard deviation using this shortcut formula? Then we need the sum of all square. Then we need to square all values. The square of this value is this, the square of this value is this, and so on. We need to add all these squares and we need to plot this value here, and the sum of all x, we need to plot this value here, and after that square it. And we have to do all of this calculation in any calculator. That is indicate that you cannot access Excel and you cannot access StatCrunch, and you need to show your work in this way. Okay, then suppose that we did it and we need to plot in the t-score will be t value. We need to plot the mean here, the standard deviation here, the sample size here, and this is the center, my expectation. My expectation is the average that this company stated from the beginning. That was the average in the previous study, and this is the average in my sample. Then the t-score here is 2.75. This t value gives me an idea how far away is my evidence from the center. It's on the right because it's positive. Okay, step number 4. Step number 4 could be either p-value or critical value. If we use critical value, let's do using both procedures. Let's do first, classical approach is critical value. To obtain my critical value, remember my critical value are the points that I am going to use as a reference to determine if my evidence falls far away or close to the center. Then the most important information to obtain critical values is alpha, type 1 error, okay? And also the distribution in this case will be t distribution and kind of test. Why kind of test? Because if we are doing a two-tail test, then we need 2 reference points, we need to split alpha. This is the area in two-tail, we need to split alpha, then the area in one tail should be 0.025, 2.5%. Then how can we obtain this value? Using table, show your work. Then you need to do this graph, and you know that in the two table we have 5%, in one table 2.5 on both sides. In the middle we have the complement of 5% is 95%. Then let's go to the t distribution table, and in this t distribution table we need to enter through the degree of freedom, which is 17. And in this table, remember, in the main body of the table we have critical value because we want to find those critical value. But in this row we have the area in one tail, and in this other the area multiplied by 2 in two tails, and in this row the area in the middle. Then we need to find this area in one tail in this row, which is 0.25. Then the area in two tail will be double, 5%, and the area in the middle should be 95%. In the intersection of this column and this row we have the corresponding critical value. Then this will be negative 2.11 and this value will be positive 2.11. How can we obtain the same critical value using StatCrunch? You have to go to Stat, you have to go to Calculator, you have to go to T distribution, and in this case, because you have the area in the middle, select between and input this, the degree of freedom 17 in this box, and here you need to enter the area in the middle. The area in the middle is 95. When you click compute, you will obtain the corresponding critical value. Actually, if you round, this critical value is exactly negative 2.11 and the other is positive 2.11. We need to compare my evidence with those point of reference. My evidence actually was 2.75. The t statistic of my evidence, the t score of my evidence is 2.75. Where is located 2.75? Actually, is located here because this critical value is 2.11. 2.75 is on the right, then my evidence fall far away from the center. Then my conclusion is, since my evidence fall far away, we have enough evidence to reject the assumption, or we reject the null hypothesis. We reject the null hypothesis. Let's do the alternative procedure, p-value, step number 4. For p-value, remember, we don't need to find critical values. We compare the p-value of my evidence directly with alpha. Then the most important information to obtain p-value is my evidence. Then remember, my evidence was condensed in this t-value, 2.75. Then my mathematical model in this case is t-distribution with 17 degrees of freedom, and the kind of test is two-tailed. Why kind of test? Because if it's a two-tailed test, my p-value should be double the extreme area. Then that is my evidence. This is my evidence. This value is my evidence. Because it's a two-tailed test, my p-value should be double. We need to multiply this area by 2. That is the p-value. Let's find this p-value using table. How can we find this value using table? To find the p-value using table, we need to go to the t-distribution table, and we need to enter in this table through the degree of freedom. In this case, the degree of freedom is 17. We need to find the degree of freedom in the table, and the degree of freedom, we need to find the degree of freedom in this column is 17. And remember, this table, in the main body of the table, we have critical values, t-values. And in this row, we have the area in one tail, the area in two tail, and the area in the middle. Then we need to find this t-value in this row, but this value is not in this row. It is between this and this number. 2.75 is between 2.56 and 2.89. And the area in one tail of 2.56 is 1%. And the area in two tail multiplied by 2 is 2%, and the area in the middle is 98%. For the other value, the area in one tail, for this value, the area in one tail is 0.5%, the area in two tail is 1%, and the area in the middle is 99%. Then remember, the p-value is the extreme area of this area. This is the p-value multiplied by 2. Then this is the area in two tail of 2.75. This area in two tail, the area in two tail of 2.75 must be located between 0.20 and 0.10. And you see this, then the p-value should be between 2 and 1%. We can reorder this inequality in this way. Then the p-value is between 1% and 2%. Remember, we need to compare p-value with alpha. If alpha is 5%, this is alpha. Obvious that 0.02 is smaller than 5%, then my p-value is smaller than alpha. Alpha, we reject the null, or we support the alternative. We can use StatCrunch to find the p-value. How? Then let's go to, in StatCrunch, to stat. Let's go to calculator. Let's go to t. In this case, despite we can use between, I prefer to use in this case a standard, only one tail. Let's find first the area in this tail to the right of 2.75. We need to enter degree of freedom in this box, which is 17. We need to enter here the area, we need to enter here this value, 2.75, and because we want the area to the right, we select greater than and 2.75, and we click compute, and I obtain the area in this tail. That should be the area in one tail in the table, but it doesn't appear in table. It should be 0.06. It's actually between 1 and 2%. And the area in two tails should be the double. Double is this area multiplied by 2. This area is 1.3%. Then 1.3% in two tails is between 1% and 2%. Then anyway, this area is smaller than 5%, which is my critical value. And that is my conclusion. We reject the null, and we reject the assumption. Then my conclusion, because we reject the null, remember my evidence fall on the right, and because fall on the right far away, we have enough evidence to reject the assumption that the mean is 5.67 at this significant level, because we compare my evidence with a significant level with this critical value. Then sufficient evidence. evidence. There is sufficient evidence to reject the statement that the mean weight of a state quarter differ from 5.67. We need to reject the null hypothesis that is equal and we support, which is the same to conclude, is equivalent to support. This evidence support the statement that the mean is different because actually my evidence fall far away. Okay, all of these steps must be done to show your work. But I recommend before you show your work, do this problem using technology. Remember, in my Stab Lab, you can send automatically this data directly to StatCrunch or Excel. Let's send all of this data to StatCrunch. We already have in StatCrunch the weight of the 18 quarters. To obtain the answers, you have to go to Stat, T-Stat, and one sample, because we have only one sample. And in this case, we have the data one by one. We don't have the summary, the data. Then click the data, and your data is located in this column, weights. Remember, you can use this function to test hypothesis or to construct confidence interval. In this case, let's test a hypothesis. The null hypothesis states that the mean weight of the quarter of the United States is 5.67 grams. And the alternative is the contrary. The mean weight is different because we have no clue. Could be bigger or could be smaller. Then here in StatCrunch, we need to enter 5.67 grams. And the alternative hypothesis is the mean weight is different to 5.67. Here we can select if it's greater or smaller, but in this case it's a two-tail test different. Then click compute and we have all answers. You can obtain all of these answers in less than 20 seconds. After you obtain all of these answers, it's easier for you to show your work. First of all, we need to verify that this sample, which is a small sample, was obtained from a normal distribution. Is the condition to use the mathematical model T distribution. You can do a normality test with this small sample using a QQ plot or a box plot. Here in graph, you have box plot and QQ plot. A QQ plot, you have the data in this column, the column of all weights, and the only thing that you have to do is compute. And can you see all 18 points are close to this theoretical line, and if we have 1 point far away, we cannot assure that this data was obtained from a normal distribution. Also, you can obtain a box plot here, the box plot of this data located in this column, and click compute, and you have here the box plot. You can edit and put it. You can draw the box horizontally like this. You can observe here that this is a box plot that is pretty symmetric and there is no outliers, and you can state that this sample was obtained from a normal distribution. You can assume a normal distribution of this population. Then after you verify that the population is normally distributed, you can do the procedure, you can state the claim, you can define the null and the alternative hypothesis, you can compute the test statistic, that is 2.75. Can you see the test statistic here is 2.75. Then you can follow the other step to test hypothesis. You could do critical value or p-value. The p-value is in StatCrunch 0.0136 and was exactly the value that we obtained here. P-value is 0.0136. It is an advantage to have all of these answers before you show your work. Okay, let's stop here.